Hey folks, Quill18 here, and welcome to another base building game tutorial for Unity. We are still working on our project Porcupine, and in this episode, we are going to take a look at our furniture system, our object system. Right now, the only example of furniture we have are the walls. Furniture in this case is just to differentiate itself from the ground tiles or any loose objects that like are inventory style objects, right? So in this case, walls are an example of furniture. Later on, things like sofas, beds, oxygen generators will all be examples of furniture as well. And so today we're actually going to look at doors, because that is going to tie in nicely with some of the pathfinding stuff we've done recently, and it's actually going to require us to resolve quite a few little extra questions about our furniture and how we want to organize them. Let's do a quick little review here of what it means to build a piece of furniture. First of all, when we've got a map loaded in here, you can click the build wall button. What the build wall button does is just tell the build mode controller that, hey, I would like to build an object of type wall at this point, which is just a string. It's just a string called wall. And then when we go and we click somewhere, this will set up a job on the queue. And then finally, when the job gets done, a furniture called wall gets placed here. Now, first thing that happens is we actually have a list of what I call prototypes of our objects. We have one sort of platonic ideal of a wall. That wall prototype gets copied and placed in a tile. So there's still this sort of wall prototype just sitting out in the middle of nowhere. Where does that get instantiated? Let's take a look at that. So in our scripts over here, under models, we have our world class over here. The world class holds all of our world map data, but in addition to that, it also has a function. How come the document outline's not populating? Do I have to like compile once? Brr. Oh, there we go. It has a function here called create furniture prototype. So let's start by talking about that. So we have a dictionary called furniture prototypes. Then we go and create one furniture prototype. It's got the string, this is the key for the dictionary, called wall. And then we actually create the prototype here. We tell it that its object type is wall, that it can't be walked through, that it's a one-by-one object, and that it links to its neighbors and sort of becomes part of a larger object. That's a hint for our walls that says that they touch each other, they combine together, and things happen over there. And in fact, this is going to be really useful later on, I think, when we start dealing with our room code, whether a room is enclosed or not. And we'll actually have to answer some interesting questions as to whether things like doors and windows and these sorts of things, if they count as being linked. And I think the answer is actually going to be yes, because it's easy to imagine, right? Let's say you can build windows. Well, and load. Well, if we drop a window in here and assume, or in this gap, right? Well, we're going to want these wall graphics to probably link up together. So we might have to change some of the code with linking, because right now they just look to see if they're neighbors of the same type. But we might want this to look graphically connected with a window as well. Although probably not a door. So I don't know, we might fudge that one. We might treat that a little bit differently. Anyway, I'm going to work on doors today, and the reason is it's going to cause us to address a few interesting questions about how we work with objects, but it doesn't require us to make any changes in the user interface, because we aren't going to have to implement, say, larger objects that aren't one by one, and we aren't going to have to deal with object rotation from a user interface point of view. So let's go through the process. What would it mean if we wanted to add a new door object? Also, by the way, this function here, this will be replaced by a function that reads all of our furniture data from a text file in the future, right? So later on, we're going to have like an XML file or a JSON file or a comment delimited file or something that's going to describe all the different pieces of furniture. It's going to be more moddable, easier to maintain, and so on and so forth. But right now, we just have a function doing that for us. So let's say we were to just duplicate this. And so we would be adding a new furniture prototype with the object type of door. We're going to want the key to dictionary being the same. And other than that, we're going to leave these stats all the same. It's by default, it's not walkable. It's a one-by-one object. Does it link to its neighbors? I guess, I don't know. Sort of 6 of one, half a dozen of the other. Let's leave it in there for now and then see how it goes. Okay, so now all of a sudden we have the ability to plop down door type objects. And in fact, as long as we added a button over here, I guess we could do that. our build wall button over here, we're just going to duplicate it, and I'll create a new one. I'll label it to build door, and the actual button text over here, we're going to say build door, and let me reorder things so that it's at the top of the list. And then the only behavior is when the button is clicked over here and we tell the build mode controller what to do. We're calling it a function, which we're calling the set mode build furniture function, which requires a string, and we just give it the object type that we're building, and in this case it's going to be door. So now technically we can start doing that, and I think we even have some images in here for our doors, although they're not really finalized, but we do technically have the door in there. And these two versions over here of the door, this might change. Right now we have the east-west graphic and the north-south graphic. We also have no animations put in here or anything like that. We might just have one type of door and actually rotate the sprite as opposed to using this. But we're not working on the visual layer yet. I mean, put in the button here as a, just for the sake of argument. But we have a lot to do before we can actually get working doors. Like right now, we could plop a door graphic that's exact like a wall, i.e. doesn't do anything. But we want more than that. So we create a prototype here, but where does the object actually get put into the world? The prototype is one thing. Where do we actually put it in the world? Well, we have a function here in our world called place furniture. Now, place furniture, mostly what it does is it just makes sure that the furniture prototype actually exists in the dictionary, that we haven't done something wrong. But mostly what it does is it calls this. It calls a function on the furniture class called place instance. So what it does is this gets passed a string, which is the object type. It looks up that string in our furniture prototype dictionary, and now it's passing the actual object, the prototype object, plus the tile, the target tile, get passed to the place instance. And then we go and, we call some callbacks and things like that. But the real work of placing the furniture is actually in this function over here. Okay, let's take a look at that. Go to declaration. So in here is where we actually place the furniture. Now, scroll down to the bottom. All this bit over here, we can ignore. This is mostly our code. If our object is supposed to link to a neighbor, we check that we have neighbors and they're the right type, and then we go and let our neighbors know that, hey, by the way, I just placed down another wall next to you. You probably want to go and update your graphics or something like that. That's all this does. So we can ignore this completely. It's not relevant in any way whatsoever. And this is, checking for a weird failure case. But what we do is we get past a prototype. We create a new instance of the furniture object. We copy all the data from the prototype, and then we tell the object, hey, you are in this tile, and then we tell the tile to try to place this furniture in it. We say, okay, so the object is told what tile it belongs to, but then we tell the tile, hey, we're putting a piece of furniture in you, because the tile wants to point back to the furniture. This can return null or false. If there's already a piece of furniture or some other error in this tile that is making this furniture unplaceable, it will return false, in which case we just return null, and this object gets garbage collected and goes away forever. So really, there's not that much going on here. There's not that much going on here. What place instance is really doing is it's creating this object and linking it to a tile. These two lines here are linking it to a tile. At the time, I believe I copied the data from one piece of furniture from the prototype into our new instance here because I was trying to sidestep a discussion about copy constructors and object cloning in C#. Because it's actually, well, all languages have this, I think. It's sort of a bit of a fuzzy idea of what does it mean to copy one object from another. There's shallow cloning. There is deep cloning. Either of them correct all the time? No. In fact, neither one of those approaches is the one we want to use for this furniture. I won't go into the details of what they are exactly, but let's take a look at the one built-in function that C# provides for us over here. What we could have done, instead of manually instantiating a new copy of this object and then manually copying everything over, this whole thing could have been replaced with, actually let's go in, boom, like that. This could have been replaced with, hey, our prototype, our proto object, do a member-wise clone of this object. So what does this do? This will create a new instance of furniture, and it goes through the current prototype furniture object and grabs every single one of its attributes, okay, in this case tile, object type, movement cost, width, height, and everything like that, and assigns it, where the hell were we? Oh, and assigns it to the new object and returns that. So it effectively does exactly what this does, with one catch. Since it's copying all the our properties, all of our variables here from one to the other, it would also copy the prototype's tile into this one. Now, it so happens the prototype in this case, the tile is just null. So it's just setting, obj.tile to equal to null, and then we set it to the correct value over here. So it's fine. And in fact, even if it was setting it, even if we're copying this object from another, like an actual installed piece of furniture to this new object, so that installed piece of furniture already had a tile. Well, so obj after memberwise copy, obj.tile would point to a tile, and we'd still override it. But it does, so it's not really a problem, but it does show you that memberwise clone sometimes can clone something that doesn't really make sense to be cloned. And that's a shallow clone, right? At this point, we're not making a duplicate of tile. We are simply having both obj.tile values pointing to the same place. A deep clone would do the same thing as a memberwise clone, but whenever it would hit one of these references, so obj.tile, it would actually do a clone of that tile, which is obviously really wrong here. But for some things, we do want a particular attribute to be deep cloned, and for other things we want the particular attribute to be shallow cloned, and for other things we don't want the attribute to be copied as well at all. So we're going to implement our own copy constructor at this point, because what this is doing here is effectively the work of a copy constructor. Now, because this is a function that exists within the furniture class, it's a static function within the furniture class, there's no reason that it's wrong for us to do this work here, because inside of this class is when these things should be known. But we can trim this function down to be a little leaner, and I like that. Short functions are easier to understand. So if we went and implemented a copy constructor, we'd be able to move a lot of this code out of here. So let's go and do that. Our copy constructors are something that are built into some languages. So for example, in C++, there's an automatic copy constructor, and a copy constructor has a signature that looks like this. It's a constructor, obviously, and it just requires another piece of furniture, right? The other piece of furniture. And then it's responsible for copying those parameters over. In C++, you will automatically get a shallow clone. If you don't specify a copy constructor, you still have one. And so you can activate it simply by doing this. So there we go. Furniture object equals new furniture, and we pass the prototype. This is what a copy constructor looks like in languages that support copy constructors. We're going to just make it here automatically. We're going to make our own version of it. So we're going to do that by grabbing all of this, cutting it out, moving it into here. And we just have to go and name these to the right stuff. This is going to be a this. There we go. So we haven't changed anything right now. Everything still works exactly the same way that it was before. One interesting side effect, though, is that we actually don't need, I was going to say, we don't need an empty constructor for furniture anymore, right? Because we were right over here just calling the default constructor an empty piece of furniture. We do technically still need it for serialization. So I guess I got to leave that in. Empty constructor is used for serialization. I still don't like that this is a thing, but I guess it's fine. Okay? And then we have a copy constructor. And since we're looking at constructors, I think sidestepping the discussion about copy constructors was perfectly legit before. And actually, we're not done. We're going to do some more things over here. We are not leaving this as is. But I can't remember what I was thinking with this static. I literally have no idea what the idea was here. Maybe this code was copy and pasted. Maybe I wrote this somewhere else first, and then I decided, oh, you know what? It should belong in the furniture class, and so I just copy and pasted it. This create prototype, I mean, I guess the create prototype name is good, but a prototype, we know now, is, there's nothing special about a prototype. It's just another piece of furniture. Is there any reason this could not just be a constructor? The only difference between what we had with the static function and what we have with a constructor is with a constructor, the creation of the object is implied. So we don't need a new. We do then work on thises over here. And we don't have to return anything because the new will automatically return the new instance. So if we do that, and then we go into our create furniture prototypes, all that changes is this. This doesn't change anything, and it's not going to be used any differently than before, but this got to be more correct than what we had before. I can't remember if there was another reason for doing it. I don't think so. So this is the standard way to actually create, create furniture from parameters. This will probably only ever be used for prototypes. And maybe that was part of it. Maybe it was a way to sort of encourage myself mentally to remember that, like, you're never going to instantiate a piece of furniture that gets placed in the world based on these values directly. You're only ever going to copy them from a furniture prototype. And maybe that was the idea the point to get across, is to use the naming of the functions and the fact that it's a static function as opposed to a constructor to guide us to remember that these are supposed to be used in certain ways. Maybe, but we're going to switch it to more conventional programming because at this point we are working with more constructors, and so let's go ahead and do that. And I don't know, whatever. So we can test right now that nothing should have changed. Everything should work exactly the same as before. We can try to load still works. Try to build a new wall. There we go. The only error we're getting is that pathfinding error, which is not really an error. It's just us keeping a note of things, and that's totally okay. All right. So that's great. All that to get to exactly where we were before. So we have this furniture prototype with doors that we can sort of kind of place. We have a button for it. I doubt that would work right now. Almost certain it's not going to work if I try to place a door. But let's, for the sake of argument, no sprite with name door underscore. Actually, we could, that's an interesting question. If I go into my resources for furniture, and let's just rename this one. Can I rename from here? Oh no, I have to rename from inside the sprite editor. Let me rename this one to just door underscore. And we're not using the other sprite at all. And we can load the world, build door, build me a door over here. Huh. Oh, the sprite's the wrong size, clearly, but it is working. Actually, why is that? Oh, because the pixels per unit is off. I think I drew it the same scale as the other one, so 32 pixels per unit should be correct. Build door. Yeah, it puts the little production graphic. There we go, we have a little doorway, and in fact, because the door is exactly a clone of a wall, we cannot pass through it here. Can't reach from one to the other. Okay. So we can place doors, but they don't do anything. Clearly, doors are going to have to work differently from a wall. Doors have a certain number of dynamic things going on. What does a door have to do? A door, so let's, for the sake of argument, go into the furniture here and make a couple little parameters that will be used for a door. A door would need maybe like a float that says like openness or something like that, right? Where conceptually something like 0 is a closed door. 1 is equal to a fully open door. In between is partially open. And then we probably want some sort of Boolean like door is opening, which is false. So if door is opening is true, then we move openness towards 1 until it finally hits 1. And then once the Boolean gets flipped to being back to false, where the door is now in closing state, we bring openness down from 1 all the way down to a 0 until it fully closes. We probably want some sort of float like door open time. So let's say it takes, I don't know, quarter second time to go from fully closed to fully open and vice versa, which implies that something can set door opening to be set to true, and then clearly our furniture here needs some sort of update function. Clearly it's going to have, just like our character has a public void update function that takes a float called delta time, and we call this every tick of the simulation. And so what would happen is our code would be something like if door is opening, then we do something like openness plus equals delta time divided by door open time. Yes. So the smaller door open time is, the bigger this gets. So this would open the door in 1/4 second, and then else openness, whoops, hitting all the wrong keys. Openness minus equals, the same thing. And then we'd clamp. Give it the clamps. Openness equals mathf dot clamp. And there's actually a handy clamp here that automatically clamps it to between 0 and 1, which is what we want. So we pass it openness. There we go. So it guarantees it stays between there. And then, you know, if the door is opening and if it goes from, if it wasn't 1 before, but now it is, probably want to trigger a callback. So this is sort of the stuff we need to get our door to work. Should this be stuff added to the furniture class? I mean, it could. We could have one, you know, mega furniture class that's got all these extra parameters, and, you know, 90% of them are unused on any particular piece of furniture because they apply to a specific function on another piece of furniture. Obviously, that's not a good way to do it. What other solutions might we have? Well, what we could have is, if I add generics over here, we could have like a sort of dictionary here with a string and either a number or something, or maybe a generic object where we have, this is our, you know, our furniture parameters, and things can be set. So instead of having openness here, we could have somewhere furniture parameters openness, you know, and set it to 0. We could do something like this, and then we could have another, say, a list of actions called update actions. And then in our update, rather than do this, we call update actions, right? And so then when we create our door, we add to its update actions array the list of functions to process every action and so on. So this would be more reminiscent of the component design model, which actually is a great idea in game development, right? It's that tug of war between an inheritance-driven, so no matter what, we're talking about object-oriented stuff, but are you deriving subclasses or are you adding more components? And for a lot of things in game design, and I've been emphasizing this throughout this, is the component-driven model is the way to go. Because again, the one example is if, list of actions is wrong. It would actually be like action, update action, then you can call it. Anyway, doesn't matter. If you think of like a monster in a typical game, what you could have is something like some sort of class structure that goes something like, you know, it's a map object that is a creature that is a monster, monster that is a witch, but specifically it's the, it's the witch boss version of it, right? So this is your class structure. Each one is derived from a previous one. And what's annoying this is like sometimes you're going to want your witch to also have similar behaviors to a warlock, right? Some of these things are going to be the same. They both cast spells. Well, I guess you could both derive them from a spellcaster base class, but what if you have something that's like, and then you have other things that are sort of like, they're a warrior base class, so then we have an orc. But what happens when you end up with an orc shaman? Right? An orc shaman which can both, wear armor and fight and, do cleave attacks, but can also cast some spells or something like that. Then how do you derive it? And that's where the problem is. And some of the languages had multiple inheritance, which are, bad and sketchy and things. And there's interfaces and there's all kinds of different ways. But what ends up being a lot easier instead is the sort of model that, well, honestly, it's the whole Unity model in that you'll have, so in Unity, you'd have some sort of creature, which is really a game object, but instead of deriving from game object, we add to this game object. Let me, game object. There we go. I was going to say it should be doing that. And we add to it. We have, this game object has, say, a mesh filter, a mesh renderer. These are components that are added in. It's not part of GameObject. We're just tacking those on. Maybe it has a capsule collider for the physics engine. Then it has something like, it has a creature component, which does things like health, inventory. Actually, we might break those down into to two separate things. And then it could have something like monster AI, and then it could have a bunch of components which are the attacks available, right? Attack, and then there, you fill out info for an axe cleave, and then it also has a spell component. In fact, maybe it has a bunch of different spells that it can use, all with their own individual callbacks, and then your monster AI just cycles through all of these, sees which ones are, or I said callbacks, I meant cooldowns, cycles through each one of these, finds one that's not on cooldown, and maybe there's a helper function on this to tell you how suitable it is, right? Like, let's say one is a healing spell, like a self-heal. Well, then in there you might have a function that says, well, only cast this if my health is under 75% or something, because otherwise it'd be a waste. So that's the component model. This is sort of the component model, but we're not going to use that because it's obviously kind of cumbersome and silly and weird. And also it's going to be really kind of, I think, a lot less good to do some serializations. I guess it doesn't matter because it would be when we create our prototypes here, after we create the door prototype, that's when we'd attach all the functions. But we'd have to be attaching all the functions here. I guess it does have the pro in that if this update actions were public and these furniture parameters were public, right? The upside of doing it this way is that when we create our prototypes, and it's actually worth talking about this, is what if the object behaviors were scriptable and therefore were part of the text file we are reading in now, in which case we actually would really, really, really want to be able to do something like furniture prototypes door dot update actions, and we want to add something to here which is some bit of code from the text file, right? So we parse the code in some way from the text file by going through a JavaScript interpreter or a Lua interpreter or something like that, convert it into a series of just, the sort of native C# sort of actions over here, and we add it to here. That's insanely powerful. And this is the way we would have to do it. God, that's tempting. But I think at this point that's over-designing things. I think if we decide to implement this later on, it will not be too hard to make the switch back. But I think right now we would be breaking ourselves trying to implement this sort of scripting thing. Wow. God, is it really that bad? I started this tutorial being like, now we're going to do derived classes. I'm going to make a door derived class from here because it's going to have its own damn traits. But shit, from the text file, we could read default parameters. I mean, in addition to this, which is just sort of common to all furniture, right? But from here, if we're iterating through an XML file, then we know that, oh, door is supposed to have a prototype. It's supposed to have a parameter, which is not public. Oh, it is. There we go. It's going to have a fern parameters. It's going to have one called openness. Openness? I don't even know if this is spelled correctly or a word or anything anymore. Which has a default value of 0. And all these things could be read from a text file. God damn. I'm actually starting to convince myself to do it this way. Shit. Because it would be cool. And there's no reason we can't do that now, because right now, rather than parsing data, because obviously we're not parsing data. Right now, all this stuff's going to be sort of hard-coded in this one function. But there's no reason, instead of a door class, right, instead of having a door subclass, we could have a series of basically sort of static functions that I add in over here. God, do I want to do this? So let's say in our models here, let's make a new C# script. This is going to be called furniture behaviors or actions. Furniture actions. I'm not convinced we're going to stick with this, but at this point I sort of want to like just go through conceptually what I'm thinking. Right, so we have this sort of furniture actions class, and then it's just a static class because it'll never be instantiated. And so every function inside of it is static. Do you still have to specify static if it's a static class? Like if I just said something like, this is the door update action, which does require a furniture gets passed in. If I have this, it's not even public. It definitely has to be public. And then over here in our world, if I add furniture actions ::, no, because it's not static. Okay. Public static. Now it should show up. Meh. Oh, because it's an action that doesn't take something. This should actually be, yeah, an action that requires a furniture. But I'd have to pass it a piece of furniture, and I don't know what that will be at this point. It'll have to get updated when we instantiate the local one. If it was a local thing here, it's almost like instead of that, yeah, see, now I'm really convinced that it's not going to be the way to go, because we'd actually have to do something like this: public void door update action that doesn't require a parameter. Because this way, because it's not a static function, it'll know this, you know. We are aware of this, and I think I could pass it furniture door. Really? What's the error here? Sorry, I I clearly was not thinking about this, right? I'm not going into this prepared. I'm just sort of thinking about things on the fly. Alias furniture not found. What are you talking about? Alias furniture not found. Oh, I don't have to do... That's the problem. It's a dot. I'm thinking of something else. So if we do this, this would go called, and we'd be aware of this. Therefore, we can do this dot furniture parameters openness, you know, plus equals. It would need a delta time. Plus equals delta time to say. So it does definitely need to float. See, I'm doing all this, and I don't think I'm going to keep it. But I just want to go through the process here. It's a learning thing. We still have that function, that's fine. And then the key is, in our update here, we just call update actions delta time. And this will just call all update actions, because this is sort of implicitly iteratable. It's like an array, right? So this will call any update actions, and it just so happens that for our wall we don't have any, which actually means it would be null. So if not equals null, then we just call all the update actions. And for our door, we would be calling door update action, which right now would just be increasing the value of this parameter over and over and over every single frame. And sets us up in a position that would be really nice if later on, instead of having the scripts be here, which is sort of an awkward-y kind of place to put it, instead of the functions, rather, be here, the functions could be parsed from a text file. Huh. And just get called with... Oh, I guess it could come out of here. Needs a furniture and a delta time. Right. Because the only difference would be if instead of being in this file, which I don't want to pollute the furniture file. I'm really apologizing to anyone who's not following anymore. This is not the way I like to do things normally. Because we can pass it to this. There we go. So then we can keep all our furniture actions over here. And then that was the problem, is that I was not using the dot. Public static void door update action. Furniture, oops, furniture actions dot door update action. There we are. Debug.log. And this function is being run. And yeah, so update actions, we pass it the furniture that is actually being updated and the delta time, and it runs here. And later on, this can be read from this can all be parsed dynamically. Wow! Because I was going to say, this whole thing, it's going to go on this whole thing about, yeah, copy constructors and whatever, and you know what, they should be. I've totally drunk the Kool-Aid on, there's a sort of a movement or a scheme of doing things that is not just C#. Java and C++, a lot of people think your copy constructors should be protected, and instead you should have a sort of a virtual public void, not void, furniture function called clone, which I guess we have a capital one here, and then you pass it furniture other, and then you simply return new furniture other. So internally, what you're doing is you're calling a copy constructor, but by doing it this way, it works a lot better with derived classes and inheritance. Yes, you can have this be virtual as well, and you can override it in subclasses as well. But specifically when you're doing things like this and you're saying new furniture, and so you're using the copy constructor. Well, in this case, we're forcing us to use the furniture copy constructor. So let's say this furniture prototype was actually a door, right? So let's say we had a door subclass. Here it was a new door, but by the time we're calling it here, we're passing it as this prototype, and it's cast as the base class, the furniture, but internally it's a door. But at this point here, we don't really know that. And we're using the furniture, the base class's copy constructor, which means the thing we're getting is not actually going to be a door subclass, which means instead of doing it this way, what you do is you call proto.clone, because this can be overridden by a subclass, which means the object that gets created here would be a door object. It still gets stuffed into a variable that is sort of cast to the base class, but then everything will work beautifully. That was the whole point of that. And now I'm not sure that we're doing that. In any case, you know what? We'll leave this in here, because this will work perfectly and beautifully still. So you have a protected copy constructor that really only gets called from the clone function over here, which is public. And that works a lot better when you're trying to make a clone of something when all you have access to is a variable of the base class. We don't actually know what this is. The alternative would be a really, really annoying piece of code where you go something like if proto is, and then, door, we don't have a door class, but if you did, and or furniture, and then you call the correct copy constructor, obj equals new, and again, door proto. So if we had a door class, you would do this, and then you have another if for sofa, and another if for this. This is if you want to call the correct copy constructor. By using that clone function, it will return an object of the right type. It'll be cast the right way. You're not returning a generic object, etc., etc., etc. Things work a hell of a lot better. We're going to leave this in because it's actually good and correct code. But we're going to put a cut in here. And I'm really thinking we're going to keep this. Even though doing the subclassing here would be great and fine. If we do this, we do allow more scripting later on. I have to think about this to make sure I'm not painting us into an annoying corner. I mean, this is not any more complicated. We have this extra layer of indirection here, but we're done. We don't need any of this, right? By literally including these, I don't know, there's like 5 real lines of code in here, plus some extra white space and, new lines after curly braces. 5 real lines of code in here. We all of a sudden, and then running our code here, as opposed to a subclass, we future-proof ourselves later on for more like a scripting system where we can have Lua scripting or something like that define our object behavior. Because instead of passing in a C# function here, we're going to pass in something that was parsed from some Lua code. God damn it. I'm really sorry that this was like a rambling, unsure sort of thing, but this sort of just developed on the fly. I was going to show like, this is a dumb way to implement it, and all of a sudden I'm like, actually, this is a pretty cool way to implement it. But again, I'm gonna put a cut in here, and I'm gonna try to think about our situation and figure out if A, this is actually a good way of doing it, B, if it's a clear way of doing it, and C, if just make sure we're not shooting ourselves in the foot later on. Technically, there's microscopically more overhead here because there's an extra function being called. But it's virtually nothing. Like, this function executes almost instantly. It's just calling other functions that do the real work. This is not overhead that matters in any way whatsoever. Obviously, we are going to have to go and instantiate these things because right now they're empty. I guess I should take care of that right away because otherwise bad things might happen. So in the empty constructor, we make a new empty one. What's the other one? Actions, update actions. Hang on. Update actions equals new this. Then actually in our copy constructor becomes an interesting question. I think that there's almost no reason in our copy constructor why update actions couldn't literally just point to the pre-existing list. Because the list, that list of actions for functions should never change as the program is running. It gets set once on a prototype, and then it's basically static at that point. If for any reason we would add, well, no, there's a possibility. I can actually see a good example. I can see a case where we might add an update action to a particular piece of furniture. For example, if a piece of furniture is on fire, we might want to give it an action called like burning. And so every update, that burning function will run, and that burning function will probably reduce the hit points of the furniture, check to see if the furniture's hit points have gone to 0, in which case it'll destroy the piece of furniture. It might also have some code that might spread the fire. But if the fire goes out, then we just remove the action from this list. Okay, so we don't want to go and just point... wow, that was a redundant line, but the idea was this, pointing to other that. We don't want to share the same list. We actually want to make a copy of the list. And the same thing with the dictionary. Does this have a clone? It does. There we go. So this is going to clone the list. It's they're still going to point to the same actions ultimately, but we're going to have our own copy of the list. And this should be fine and non-complaining. Oh, actions don't need to be instantiated this way. Right. It's okay. By default, it'll just be set to null. And the clone, I believe this will work. I'll double check. Again, I'm doing this on the fly. I'll double check that this actually returns what we want it to return. That's okay. The furniture parameters definitely needs a clone of that. You don't have a clone? And you don't have a copy? Oh, that's what we can do is we can say new dictionary. That's right, because it has a copy constructor of using the other dot. And I'm just going to use a this dot to be explicit as to which one we're dealing with. So this will make a copy of that dictionary. All the parameters that were existing in the prototype will exist, and the same. It'll start with the same default parameters, the same default values as the prototype in there, which is good. And yeah, we just have, oh, and then there's the prototype one. So we just need to make sure that furniture parameters is actually instantiated to something, because over here we're going to start assigning things, and we want furniture parameters can't be null. Update actions can start null. That's perfectly fine. Even though it looks like you should already have an array before you do this, it's fine. You can have update actions start as null and then add things to it. Is there any chance this is like vaguely correct and not horribly broken? Can implicitly convert system.action to system.action furniture.float. Oh. Cast it as that. Again, I'll have to double check that that clone function works properly. And it don't. Oh. Right. Furniture.clone to there. Oh, hold on. Yeah, I'm doing this wrong. The clone function doesn't need another. We're just copying our cells, cloning this. There we go. We're returning a clone of our cells. And I don't think I've actually broken anything. Well, part of it is that update function is not getting called anywhere yet. Ah, no, I did break things. Damn it, I keep wanting to end this video here. Oh. If other update actions not equal to null, then we copy it. I think that's what's going on there. It was returning an error because that didn't exist yet. Okay. Build wall. Okay. Build door. Okay. And then go there. And that update function's not being run yet. But I actually think we have a really good setup here. Okay, I gotta end this video, and then I gotta actually, like, sit in a corner and think about what I've done. See you next time, folks. Bye-bye. Thank you very much to all our January supporters over at patreon.com/Will18Creates, and these mic check supporters. We've got Alexander Gutler, Andre Odendal, Neil Blakely Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toyson, Marius Field Vold, Disco Geek, Ole Peter Talgo, Julian Auger Lafont, or Auger Lafont, I should say, Steven Stagger, Michael McClintock, Kale the Quick, Drazion, Wes Oldenbeving, Craig Mortel, Nail or Nale, I don't know, Vikstrom, and Andrew Henninger, and everyone who has watched, shared, favorited, and subscribed to these videos, and left comments as well. You guys really keep things going. Thank you very much for watching.